Welcome again. Today, we're going to explore the linear search algorithm and walk you through step-by-step coding of a linear search example in Python. By the end of this video, you'll have a solid understanding of how linear search works and how to implement it in Python. This video is a part of the algorithm series where we plan to cover different algorithms gradually. Linear search is a basic searching algorithm that checks every element in a list or array one by one until the target element is found or until the entire list is searched. For example, we can consider a list of 5 numbers 7, 15, 24, 27, 0. The indexes will be 0, 1, 2, 3 and 4. Let's say we want to find the number 27 from the list. Linear search starts from the beginning of the list and compares each element with the target element until it either finds a match or reaches the end of the list. So it will start from the beginning, index 0, which has 7, it will compare 7 with our target number 27. 7 doesn't match with 27, so it will move to the next index, index 1, where it will search for 27. But index 1 has 15. So it will move to index 2 containing 24, which also not a match. So it will move on to the index 3 where 27 is found. Let's define the algorithm with some steps. 1. Start from the first element of the list. 2. Compare the current element with the target element. 3. If it matches, return the index. 4. If not, move to the next element. 5. Repeat steps 2 to 4 until the end of the list is reached. 6. If the target element is not found, return -1 to indicate it's not in the list. Now, let's code a linear search example in Python. First, we need to import any necessary libraries. Let's import random library to generate random number for our list. Next we will define the main function. Next, let's create a list to search through. We are using random integer function from random library to generate 10 random numbers for our list. The random.randint function takes 2 parameter, starting and ending range of the random numbers. Next we will print the list to see the generated numbers in the list. Now, we'll define a function for linear search. The function will take 2 parameters, one will be the array or the list containing the numbers, and the other will be the target element or number that the algorithm will search for. We will run a for loop that will iterate through the elements, or in this case the numbers, in the list. Inside the loop we will add a condition that compares our target number with the current element of list for each iteration. We will return the index of the target number if it is found. Otherwise we will return -1. Finally, let's perform the linear search on our list. First we define a target element or number that we will search in the list using linear search. Instead of defining it inside the code, we will take it as input from the user. Now we will call our linear search function and pass our list of number with the target number. It will return either the index of the number if it is found, or it will return -1. So, we will add a conditional statement here. We will check if the return value is not -1, which will mean the target number is found in the list, and we will print the index of the number. The else condition will cover the case where the target number is not found in the list. We've coded a linear search function, and now we'll demonstrate how it works with our list. Let's run the code. Here we can see the generated list contains 88, 13, 33, 90, 8, 8, 66, 43, 163. Let's give 66 as input for our target number. Our target element is found at index 6. We can also visually verify it from the output on the terminal. Let's try another case where we will search for a number that is not present in the list. This list contains 95, 66, 67, 58, 27, 96, 74, 18, 16 and 82. We will set our target number as 100, which is not present in the list. Let's run the code. The code outputs in the terminal that this number is not found in the list. The search is performed step by step, comparing each element with the target element until a match is found. Let's look at the time complexity of the linear search. Linear search has a time complexity of big O of n in the worst case, because it may need to search through all n elements in the list. So if we plot the time complexity against the size of list, it will be something like this graph. Linear search is a simple algorithm for finding an element in a list. It checks each element one by one until a match is found. Today, we learned how to implement linear search in Python. Thank you for joining us in this session on linear search. See you in the next video.